Comparing proportional relationships given different forms. Three pumps are pumping fluid at a constant rate. For each, the amount of fluid pumped depends on the time, as shown below. We're going to answer the following questions about the pumps. But first, let's look at what each proportional relationship sets up. It says that they're flowing at a constant rate. So real quick, let's review what rate is. A rate is a ratio of two quantities, and we're going to have different units. But we can leave that part out because that's quite obvious. That's what our rate's going to be. It's going to have two different units. And so our two units are going to be hours and fluid, and it says that the fluid pumped depends on the time. So we're going to have, our ratio is going to be fluid over time. So that's what our rate's going to be. We're going to be talking about fluid over time. Okay, let's go answer our questions. What is the rate of each pump? So what is the ratio of our two quantities? So let's look at pump A. And the way to find the rate is they're asking for the unit rate. They're asking for liters per hour. So they're asking for how many liters does it pump in 1 hour. Well, here it says that it pumps 70 in 1 hour, 140 in 2 hours, and 210 in 3. So what we have to do is we have to set up our rate. So we have to tell how much fluid it pumps per hour. So we're going to do pump A. And pump A goes 70 for 1 hour, and that's going to be 70 per hour. But it also goes 140 for 2 hours. So in order to get this to 70 over 1, we're going to have to try and reduce it. So it's 140 over 2. And in order to do that, we're going to divide it by 2, and we'll see that it equals 70 over 1. And then third, just to make sure, we have 210 over 3. And 210 over 3 reduces to 70 over 1. So our rate is going to be 70 liters per hour. Now we're going to do the same for pump B and pump C, and see if you can predict them yourself. So for pump B, we're actually going to have to now look at our graph because it gives us points. It says that for 1 hour it pumps 80 liters. So my fluid is going to be 80 to 1. For 2 hours it goes to 160, which is 80 more. So we'll have 160 over 2. If you reduce that, it's going to be 80 over 1. I'm establishing a pattern here. So for 1 hour, it's 80. For 2 hours, it's 60, but that means that it's changing at 80 liters per hour. Let's see if it stays consistent. If I go up another hour to the third hour of pumping, I will have pumped out 240 liters of fluid. So we'll say for the third hour, we'll have 240 liters over 3 hours, and that's going to reduce to 80 over 1 again. So our rate here is 80 over 1, or just 80 liters per hour. In pump C is actually the easiest. F is the amount of fluid in liters, T is the time in hours. And so it's saying 90 liters per hour. So it's saying F equals 90 liters per hour. And so 90 per 1 hour is actually just going to be our rate. So if we look at this, the 90 is our rate. And we're going to learn more about this in the next video actually. So it's going to be 90 liters per hour. So this part was a little bit simpler. So we'll say 90. Now it's going to ask us which one is the slowest. Well, if this one's going 70 liters per hour, this one's going 80, and this one's going 90, it's quite clear that pump A is the slowest because it's not pumping as many liters per hour. And now, the final question, how much fluid does each pump in 3 hours? And so we'll go through and look, and pump A wants to know how many liters for 3 hours. Well, that's right here. It's going to be 210. The information's already given to you. Pump B, how many liters after 3 hours? Well, that one's right here also. 3 hours, 240 liters. But pump C is a little bit different because it only gives us an equation. Pump C only gives us an equation. It says that it's 90 liters per hour. So we'll have to do 90 liters per hour for 3 hours. So we'll do 90 times 3, which should give us 270 liters total. So remember, rate is a function, a rate is a ratio of two quantities. And so when you want to find the rate in liters per hour, you just set that ratio up and reduce it.